Welcome back to the Leetcode Bind 75 solution series, where we'll be solving every Bind 75 question in Rust. We'll be going from top to bottom on the list you can find at leetcode.io/practice. And as usual, create a unit struct called solution, and let's begin. So today we'll be doing episode question 3, okay, two sum. And the question says, given an array of integers, nums, and an integer, target, return indices of two numbers such that they add up to target. You may assume each input would have exactly one solution. You may not use the same element twice. You can return the results in any order. Okay, so it says nums equals to this target is 9. So 0 and 1 because 2 plus 7 is 9. So 3, 2, 4. Target is 6. So it returns 1 and 2 because 2 plus 4 plus 4 is 6. The index 2 and the index 1 is 2, the index 2 is 4, and 2 plus 4 is 6. Here the index 0 is 3, the index 1 is 3, 3 plus 3 is 6. So we should return two indexes such that when you add the numbers in that position, you get the target. Okay, so let's copy this and let us paste it here. So the way I like us to think of this problem is, let's assume we are given an array of numbers. Let this be 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we have 9 numbers here. Now, let's assume we're given a target. Let's call that target 10. Let's say we're given a target called 10. We check each position. We bring out 1, for example, and then we have 1. Then we say, okay, 1 plus 2 is 3. That won't work. 1 plus 3 is 4. No. 1 plus 4 is 5. No. 6, 7, 8, 9. 1 plus 9 is 10. So we return this index 0 and this index 8. So this is going to be kind of like a, should I say, Fibonacci complexity, because we'll do 1 all through, then we're going to count for everything here. Then we go to 2 and then we count for everything here. 3 and then we count for everything here. 4 and then we count, and then we just keep going all the way. So that's going to be 9 plus 8 plus 7 plus 6 plus 5, 4, 3, 2, 1. So yes, that is not very efficient. So the most efficient method is to use a hash map. I will use this rounded rectangle to represent a hash map, and I will put a line in the middle. So this hash map, what we're going to do is, given this target 10, we will go to the first number, 1, and then we say, okay, 10 minus 1 is what? The answer is 9. Does this hash map have a 9? No. So what are we going to do? We will put the 1 inside the hash map. I will put the index of 1 as the value. So the key is the number and the index is the value. Next, we go to 2. We say, oh, then we come over here and then we do this. We say 10 minus 2 is what? That is 8. Then we say, does this hash map contain an 8? No. Then we put 2 inside here and we put 1, and it just keeps going. So we get to 3. Let me clear this. So then we have 10 minus 3, that is 7. Hash map does not have 7 inside, so we'll put in 3. I will put in the index, which is 2. And then we just keep, doing this over and over again. So eventually we would reach 9. And then when we are at 9, we have 10 minus 9, that is 1. Does this hash map have 1? Yes, it does have a 1. So what are we going to do? We'll return the index of 9, which is 8, and the index of 1, which we'll get from the hash map, which is 0. So we'll have an array of 8 and 0. So let's implement that quickly, doing the normal way and then with the Rust way. So Firstly, according to what we said, go through each item, check for the difference between the target and the item in a hash map. If it does not exist, put the item inside the hash map and go on to the next item. So let's do that. Let number map, say let number map equal std collections hash map. This is where you find it in the standard library, and new. But what type of hash map? Let's specify the type. It would be an i32 hash map, which means the keys are i32. Let me just collections hash map i32. The keys are i32 and the values will also be i32. So we'll say for I in 0 inclusive, nums dot length exclusive. So this will start from 0 and stop at the number just before the end of the array, which is exactly what we want. What are we going to do next? We get the difference. Let difference equal to target minus nums I minus the number in that position. And then we say if let sum, if there is some index inside the hash map, number map. So we try to get the difference. We say and difference. So just like we discussed here, we look inside the hash map for the difference. For example, at 1 we're looking for 9, at 2 we're looking for 8, at 3 we're looking for 7, and just keep going that way. So now let's assume we're at 1, we're currently looking for 9. And if we do have a 9 inside, what should we do? We should return a vector, and that vector will contain the index as i32, and let this be index. The index of the current number and the index of the difference which we got from the hash map. So to return this. But else, if this does not happen, we should push into the hash map, number map dot insert. We should insert what? The number nums I and the index of that number I. So this is exactly what should happen. Let's just return an empty vector in case it does not go. So let's just say return vec new. So if I copy this and paste this into this place and run, let's see what happens. Good, everything works fine. Now things are about to get a bit complicated. Let's do this the Rust way. So what are we going to do? First thing is we have our hash map. For this for loop, we'll be using an iterator instead of the for loop. So what do? We say nums.iter enumerate. So enumerate will actually give us the index of that item inside the vector. For example, this is a vector of i32s, just like here. So when we use nums.iter, we just have this, an iterator over just the elements. So we get 1, 2, 3, 4, 5, 6, 7. But when we call with enumerate, we get over the element and the index. So it's kind of having 0, 1, 2, 3, 4, 5, 6, 7, 8, which are the indexes of the elements. So we will iterate through both in a tuple dot take while. Now, what should we put inside the take while? Take while will make the iterator continue the iteration until the predicate inside evaluates to false. If it never evaluates to false, it will just iterate through the whole thing. But at the point where it evaluates to false, then it stops the iteration. Now, what is going to be the predicate? Okay, so now you can see this is and use side, this is and i32. So we're going to have to do a bit of dereferencing here to get the values. So the take while, what are we taking? So this will return true based on something, false based on something, and if we ever return false, the iteration stops. What will we be checking for? Just like we explained previously, we'll be checking for if the hash map contains the difference we're looking for. So how do we do that? Simple. Let's get back here. So we say if number map dot get. So right, you can see here we're dereferencing to get just the values, a double dereference. Okay, this should be n. So you can see it is a double reference, so we'll do a double dereference over here. Now we are going to get the difference, which is target minus the number inside. So let me just write number to make this more intuitive. Number. So target minus number. It will check if the hash map has the difference. Let difference equals target minus number. Now, if the hash map has a difference and it is none, so this would return an option which can evaluate to some or none. But if it evaluates to none, it means it is not in the hash map. So if it is not in the hash map, what should we do? We should insert number map dot insert. What are we inserting? The number itself, so star n, and the index star I. Number map dot insert these, and then you will return true, else just return false. What are we doing? Let me explain once again. So we have a number map, and if the difference, which in this case would be 9, let's say the target is 10. Let's say we're in the first position and 10 minus 1 is 9. If 9 is not in this array, we put 1 and the index, which is 0. Simple as that. That's exactly what we're doing here. And then since it does not contain, we return, yes, truly it does not contain. But false means it contains. And at that point, we break or stop the iteration. Now, let's save the index inside a variable. Let mute index equal to 0. We're going to end this here. Now, finally, we'll say that for each item, for each iteration, which we have x, and then we have I, and then we have n. What are we going to do? This index over here, we will set the value of the index to the value of I. This is exactly what we'll be doing. Let's save. Let's wait for the errors. What does it say? Cannot convert usize to an I32 as I32. What does this say? Local variable with a similar name exists, I. So I want this to be number. So what does it say? Expected so double the reference. This works fine now. So that for each, a single tuple argument, but it takes two different arguments. So this should be a tuple. Now, yes, everything is fine. Now, what are we going to do after this? We'll say once the iteration breaks, we say let current index equal to index plus 1. And why is that? Let me get my equal to. And why is that? Because this iteration, if we do find the difference inside the hash map, it would break before it reaches this. So this will have the index of the number before the correct number. I hope that explains for you. So, for example, in this case, we're looking for 10. So if we get to 9 and then we see that, oh, a 1 does exist, index will still remain 7. It has not yet become 8. So when we break out of the iteration, we have to add a 1 to make it have the value of 8. And now, so this is why we have to add 1 to this. Then we say let result, which will be the answer, equals to a vec. Then inside this vec, we'll say index. No, we just simply store the current index, and so let current index is this, and we get the difference the entry of the difference from the hash map. So I guess also here we can say let difference equal to target minus nums current index. So over here, let this be this, okay. So over here we say number map dot get, and what will we be getting? The difference, which we know will be there, difference dot unwrap, since we know it will be there, and dot to owned. Now this expects a and i32. We found an i32, so we use the and this should also be an i32, so we change this to as i32. So we return results. It's as simple as this. So yeah, I know it's a bit complex because this is just the Rust way to do this the Rust way. And now this solution should work. Let's paste this. Let's go back to the problem. Confirm. So let's run. Let's see. Good. Everything got accepted. Now let's submit. And you see it there, 2 milliseconds. 2 milliseconds. Yes, so this is exactly how you do this, the Rust method with all the iterators, enumerate, and take while. Take while is a very useful function to continue the iteration or break it at a point where you would like. And you can also do, it has the added benefit of doing computations inside the take while closure. Yeah, I hope you enjoyed this video. Make sure to subscribe and see you in the next one.